Okay, transformations of functions. Let's start talking about vertical shifts. Now, you're going to learn about all these different parent functions, right? This one is the absolute value. Looks like this. That's the basic parent function, absolute value. The original graph is this purple one. The transformed function is this blue one. And you can see by looking at this point right here that that is now up here and it has increased by 1. This is how you show that on a function. Show that it's been increased by 1, moved up 1 by adding 1 on to the end of it. Likewise for when you're shifting down, if you want to shift it down 2, then you would subtract 2 to the outside of the function. Okay, let's look at this one right here. Now, if you look at the original is right here, and it's a square root function. Looks like this originally. The graph, and if you look at these key points, sometimes there's key points on the graph that you can look at. This is a key point for the square root. Instead of at 0, 0, now it's been moved over here, and it's gone to the left 2 spaces, right? 1, 2. So 0 to -2 moved left 2. That's what's happening as far as the graph is concerned. Now tell me what has happened to the function. It was just the square root of x. Now it's the square root of x plus 2. So as far as horizontal shifts go, when you look at the graphs, here's the original, the purple one. Again, key point for absolute value. Now it's moved over here 3 spots to the right. And that means inside here, inside the absolute value, instead of just x, now it's x minus 3. So let's go back to these couple first ones. So vertical shifts. This was up and down. When you shifted something up, you added 1 to the end of the function. Nothing changed inside for the absolute value. Nothing changed inside those bars. When it was down 2, same thing. You just subtracted 2, but you did it to the outside, to the whole function, right? Nothing went inside. This is funny because I'm quote unquoting my fingers and you can't see it because this is, you can't see me, I can't see you. All right. So then when it comes to moving left or right, now we've gone inside, here I'll write the quotes on there, inside underneath the square root. Over here at the absolute value, we've gone inside the absolute value bars, right? And it's going to be similar for the rest of the parent functions. There will be an inside and an outside. So outside meaning to the whole function, these vertical shifts. Inside meaning, okay, did it change where the x is placed? In the square root function, x is underneath the square root. Now all of a sudden it's x plus 2. That's happened inside. It's a key word right there. Okay, the other thing we need to talk about is the fact that we went left 2. We went from 0 to -2, but inside here, it's actually plus 2. What happens when you go inside, right? You change just the x, everything's backwards. I went left 2, that actually means I add 2 on the inside. Inside is always, always backwards. Write yourself a note. Inside, in quotes, is always backwards. And what I mean by that is you would think, oh, I'm going left, I'm going negative, so I would subtract 2. Nope, if it's inside, it's always backwards. And you're going to see that with a couple other transformations too. Look at the next one. Oh, this was the right 3. Okay, we're looking at it, we're thinking, oh, it went from 0 up to 3, but check out what's happening inside. You're subtracting 3 inside. I know I wrote it there, but I want you to see it as one full sentence. Subtract 3 inside when it's actually right 3. Again, it's always backwards when it's inside. Always. You'd think it's plus, it's actually minus. All right. Another type of transformation is reflections. So our original, again, is this absolute value. You've got the original absolute value function here. and then all of a sudden everything that's up here has been flipped as if we folded it across this x-axis right here, and it now is down here. So these points all move down there, these points all move down there, and it's been flipped upside down. So when you flip across the x-axis, then all of a sudden, bam, there's a minus sign. Basically, you change all the signs outside. So just putting a negative out in front is usually all it takes, but sometimes you've got to go through and change a bunch of different signs, just not on the inside. And you'll see examples of these. Okay, what about a reflection across the y-axis? So now this red one is the original, but all of a sudden now all these points have flipped over here to the other side of that y-axis. So now it's over the y-axis. And that's when it's a reflection and the negative goes inside, right? I'm going to use my quotes again. Can't see them when I do them, so I got to write them. Inside. So when you're making a change, if you're going reflection over the y-axis, then you put the negative inside with the x. Reflections. That's kind of it. Reflections are one of the easier ones. You have to just flip it either over the x-axis or over the y-axis, and the only change is some sign changes. So this one right here, the negative went out in front. This one right here, the negative goes inside with the x. All right. Okay, last two types of transformations are vertical stretches and shrinks and horizontal stretches and shrinks. So as far as a vertical stretch is concerned, the yellow one's the original, or orange, or whatever color that's supposed to be, right? Here's the original. It's a regular little parabola. The parent function looks like that. Now all of a sudden, all the points have changed. This point, let's find a good point. This point has now become this point. This point has now become that point. So what I've actually done is I've taken all these values and I've made them bigger. I've stretched them. We call it a stretch. So picture me grabbing, it's a ghost. Picture me grabbing the ends of these right here, right? So picture my hands grabbing right here. That's my hand. That's a horrible hand. Let's try that hand again. Oops. Okay, just a little technical difficulties. So here comes my hand in here. Hey, my thumb's folded, so don't think it's like wrong. That's my left hand. And here's my right hand. So I'm supposed to grab the ends of the orange ones. Anyways, so pretend I grab this end right here and this end right here, and I pull it up, but it stays right here in this point. So what would happen is it's kind of like an elastic. It gets skinnier. If I were to pull these up, it really does help when I do a physical representation of it, but you know, I can't with a video. So anyways, picture me grabbing these orange ones and pulling it straight up while this stays in this point. Think kind of like an elastic. Okay, sorry, back to it. I moved my picture, so now nothing's lining up. Let me see if I can get it to line up. There we go. Okay. So let's talk about equation-wise. Here's the parent. Here's the new one. You'll notice that the change here is that I multiplied by 2 on the outside. Inside would have happened just to the x, and I'll show you that example in a minute. So check out what happens to the points as far as this is concerned. So this point right here, the original, was 2, 2. 2, 2. This point right here was, 1, 1. It's counting by halves. Darn it, 2, 2 sounded so much better. Okay, this point on the orange graph is 1, 1. This one over here is negative 1, 1. But now if you go up x equals 1 to this point on the new one, now it's 1, and 2.5. It's changed. So those points are going to move each other based off of whatever you're doing. This is just pause. You guys love it when I do this. This is not the correct graph for this equation because it should have landed right here at 1, 2, because I would have multiplied this by 2. Scratch that. Anyways, rewind. I'm not going to because I hate editing these videos, so I'm just going to erase it and pretend it didn't happen. Sorry. Multiplying by 2, vertical stretch. So you can guess that with a vertical shrink, I'm back on track, it's all good, we're going to multiply by 1/2. Now it's not necessarily that I'm multiplying by a fraction, because 3/2 is a fraction. It's whether or not I'm multiplying by something bigger than 1 or smaller than 1, but still positive. So in this case, again, picture me grabbing the ends of this graph right here, but instead of pulling them away, I'm going to push them down. So now I'm pushing down, and these points are going to move down. So all of these points are going to go down, which is called a shrink because it's shrinking the graph. Another word that we've used is compression, which I think is kind of more fitting. It's compressing it, it's pushing it down. So again, we multiplied by that. Now looking at a horizontal stretch, as far as horizontal goes, this blue one's the original. And what I've done is I've taken and made that blue one. Now we're going horizontally. So now it's kind of like I'm grabbing, oops, the end of the blue one. And I'm pushing it this way, which is making it bow a little bit. The best way to think about horizontal is if you're stretching, it'll get farther from the x-axis. And this is the weird part. I multiplied inside. We know that. With horizontal, it's inside. And I multiplied by 1/2. Now, wait a minute. If this is a stretch, and in this other example, when it was a stretch, I multiplied by a big number. Not a huge number, but you know, I multiplied by a 2. Here, to do a shrink, I multiplied by a fraction. Makes sense. You're shrinking it. You're making it smaller. But then here, I've identified it as a horizontal stretch, and I'm multiplying inside by a small number. Well, guess what? Inside is always backwards, horizontal. Always, yep, that's not a W. Always backwards. Always. So if you thought, oh, it's a stretch, so I'm going to be multiplying, like the vertical one, by 2, then it's actually the reciprocal of it. Reciprocals. So let's look at this next one. This next one's a horizontal shrink. Whoops, sorry. Typo. I correct that, don't I? Duh. Copy and paste. Talking to myself. All right, absolute value. Here's what it looks like originally. That's the parent function. If we're doing horizontal, then we're going to go inside and change it. Now, if I'm doing a shrink, and this is the red one's the original, the blue's the new one. I'm shrinking, right? I'm pushing it down. Then you multiply, but notice inside it's a 2, not a number, not a fraction smaller than 1. So again, we multiplied inside, multiplied by 2. This is the reciprocal of the value we're actually shrinking by. So I know this went kind of fast. This was just kind of showing you all the different types.